1 by v square t of t d square t by dt square. What does this tell me? This is something very interesting. You see, the left hand side depends only on the variable x, small x. The right hand side depends only on the variable time, small t. How can these two be equal?
They both must be constant.
They both must be. Very nice. You solved my problem. They are both equal to some constant. Because for all values of x, for all values of time, right, if they have to be equal, they have to be some constant. Otherwise, it can't be possible. So, which means I get two of these equations. One is this d square x by dx square minus k x is equal to 0, and the other one would be d square t by dt square minus k v square t is equal to 0. So by doing this, what I have done essentially is to make we start with a partial differential equation. So this is a partial differential equation of which order? Second order. What I have done is to, it's a linear equation. What I have done is to break it down into two ordinary differential equations, each of second order, and both of them are linear. So these are linear ordinary differential equations of second order with constant coefficients. So these are constant. The velocity of a wave is constant. Capital K is constant, as we've said. This is constant, right? So I see in the maths lecture you've already dealt with differential equations. Not yet? Okay. Okay. So anyway, rather than solving it, we just go about and see what the solutions are. So, all I need to see is what could be the value of this capital K. So, if I think of everything, then this capital K could be 0, it could be less than 0, it could be greater than 0. If you think of capital K, so let's just take one of these equations. Maybe write it in a more generalized format, d square y by dx square minus k y. So y is a function of x, okay? Nothing more. So let me write it like that. So if k is equal to 0, then I don't have any solution. Yes? No? If capital K is equal to 0, then all I get is d squared y by dx square is equal to 0, which doesn't give me any solution. It gives me a straight line ax plus b, which is not a valid solution of the wave. Because then I'll have to put my boundary conditions over there, which says that when x is equal to 0, so let's say the solution that is given is ax plus b, y is equal to, that's my solution, right? Yes? So when x is equal to 0, it gives me b equals 0, because y should be equal to 0. When x is equal to L, then it's a times L. L can't be 0, so a has to be 0, which means that the solution that gives me is y is equal to 0. If y is equal to 0 means I don't have any displacement, which means that there is no wave. Well, as such also, if you think, I mean, rather than going mathematically, it's a linear equation. So it would look like go like that and not come back and form a wave. So the other thing is that k could be greater than 0 or k could be less than 0. I'll take the example of k less than 0 and show how k greater than 0 also comes out of it. So let's say capital K equals 0 gives a trivial solution, and again we scientists don't trust maths. Yeah, we use it but we always don't trust it. Otherwise I would have taken this solution and made the wave vanish. So no rope tricks. Now let's see if k is less than 0. If k is less than 0, then let me write k is equal to minus of k square, where small k is a real number. That will ensure that capital K is negative. Okay. So if that is the case, then I'll have my equation as d squared y by dx squared plus k squared y is equal to 0. And what kind of functions do you know if I take a double derivative of function gives back function? Sine and cos, in more general, an exponent, right? So I'll take the more general form to start with, and I'll say okay, let's use this. So d square e to the power, so let's make y is equal to e to the power some constant, I'll just keep that, times alpha x. Now the constant could be minus, plus, could be some number, let's see. So what it gives me is double differential would give me alpha square y plus k square y equals 0, or which gives me alpha is equal to plus minus ik. Right? So I have two solutions over here, that y is either equal to e to the power ikx or it's equal to e to the power minus ikx. And you can verify for yourself that both these solutions are valid, of course, and a combination of these solutions like C1 plus C2 is also a valid solution. You can check that. Physically, what does this mean? It says that this particular wave is also a solution, and this particular wave is also a solution, and the sum of these two is also a solution.